Today we shall be doing the free body diagram, or what we call as force diagram. This free body diagram or force diagram technique that is studied under laws of motion. You know, in your entrance examination, primarily for IIT, JEE and PMT, there are questions on blocks, pulleys and inclined planes. And these questions, they can be well understood and they can be done if you know this technique, force diagram or free body diagram technique. Now, what is this free body diagram method or technique? Free body diagram is primarily a method of breaking a problem into smaller pieces, then trying to solve this smaller piece individually, and then try to get the whole answer. So it is more or less, you can say, it is divide and rule policy. So now what is that? How we go about it when we apply free body or force diagram method. In free body diagram method, when you intend to draw a free body diagram, then there are few basic steps. Just follow these steps and you will get the answer. The number one is, first of all, you isolate the body. Then second is draw forces. Then third is you can apply F is equal to ma, Newton's second law form. F is equal to ma, where F stands for the resultant net force, mass and acceleration. And using these three, that is, first of all, you isolate the body, then you identify the forces, draw the forces onto the block, etc. of the body. Then third is F is equal to ma. These three basic steps, and you can get the answer. So let me write it down, what are the basic steps we need to follow when we apply free body diagram method. So first of all is isolate the body. Second is draw forces, and third is apply resultant force is equal to mass into acceleration. I'm just using this, you can get the answer. Now let me take a simple example where onto a, let's say, table, there is a block of mass 1 kg. Do not say the weight of the block is 1 kg, it is mass is 1 kg. Mass is a scalar quantity, weight is a force with which earth pulls the body towards its center, and that is m into g, mass into action due to gravity, and weight is in Newton. So if I take g as, only for convenience purpose, 10 meter per second square instead of 9.81 meter per second square, so that the calculation parts become easy and we can spend more time understanding the concept rather than getting into calculations. So over here, the weight of this body is m into g, mass is 1 kg, g is 10 meter per second square, so weight is 10 Newton. Now isolate the body. If I intend to follow it, isolate the body. I have isolated the body, 1 kg. I have not lifted it up. I have only, for the diagrammatic purpose, I have only moved it slightly up to create a space, but physically I have not lifted it. Then is draw forces on it. What are the forces which are acting on the body? One external force which is acting is Earth is applying a force of 10 Newton, m into g, 10 Newton. If Earth applies a body onto the body, a force of 10 Newton, this also applies a force of 10 Newton onto the body. Reason being, to every action there is equal and opposite reaction. Please do not make a mistake of, that is, Earth applies more force on the body and body applies less force on Earth because it has got a less mass, and or it has got a more mass, so it is going to apply more force. No, that is not the appropriate logic. Newton's third law says, to every action there is equal and opposite reaction. So if this is going to apply a force of 10 Newton downwards, this is also going to apply a force of 10 Newton upwards. To every action there is equal and opposite reaction. And number two, action and reaction, they are always on two different bodies. Do not make the action or reaction on a same body, that is not possible. Generally in your books, the earth diagram is not shown. We are not bothered about the forces which are being experienced by the earth, so that's why it is not there. It is not shown in the books. Now because of this force, this body, it has a tendency to move towards the earth, to move down. As a result, this applies a force onto the earth, let's say F. So once again, I'm not in a hurry to get the value that this force is 10 Newton or mg. Do not be in that hurry. That is to find the value. Follow the method, answer will come by itself. If this pushes the table downwards, then this table will also react. The surface of table will also react. If it pulls it down, pushes it down, then it will push it up with the equal force, with the equal might. To every action there is equal and opposite reaction. Action, reaction on two different bodies. For earth and block system, to every action there is equal and opposite reaction. We have done it. So now, in the life of 1 kg mass, there are two forces which are acting, 10 Newton downwards and F is acting upwards. So these are two forces. Do not make this force downward, which is generally a mistake which is committed by the students. So this is the force is 10 Newton downwards and this force F is upwards. Now, onto this body there are two forces, 10 Newton and F. Overall, I see that this block is stationary over here and this remains stationary. If this is not moving, it is not moving and it remains to be stationary, it means there is no change of velocity in either way, be the magnitude, be it the direction. So it means the rate of change of velocity is equal to 0. It means acceleration is equal to 0. It means the net force is equal to 0. If the net force is equal to 0, it means the upward forces, they have to be downward forces. That is, F should be equal to 10 Newton. If F is greater than 10 Newton, then this block should have been accelerating up. And if 10 Newton is greater than F, then this should have been accelerating down. This block is neither accelerating up nor accelerating down, so that's why F is equal to 10 Newton. Please do not make a mistake of that because this is not going up. In Newton's second law, which is a derived form, F is equal to dp by dt, when we say F is equal to ma, it is acceleration. It may be possible that this may be going up with a constant velocity, right? So do not say it is going up or down. It is the word is used, whether it is accelerating or not. It is not accelerating. So that's why F is equal to 10 Newton. Now, the same thing what I said, that is, don't confuse between the velocity and acceleration. Let me take one or two cases of that simple form only. Now, I say, let's say the same thing. This is in an elevator, vertical lift which is there, and this is going with 2 meters per second square. What is the force? What is the force this block 1 kg is going to apply onto the floor, onto the table? Now let's say, I'm interested in that. The force diagram precisely remains the same. But now the third thing, F is equal to ma. Let's see about this. If this goes with 2 meters per second square upwards, and there is an observer who is there onto the ground, because finally it is an observer when we talk about the frames, inertial frames and non-inertial frames, so there has to be an observer who finally writes the equations. So this observer is going to write the equation for this. He sees that this lift, suppose this is a glass lift, and the whole lift is going up with 2 meters per second square upwards. So he will see that the block is also going with 2 meters per second square upwards. It doesn't happen that is you get into a lift and lift goes to the 6th floor and you go to the basement. That doesn't happen. So you go with the same acceleration that of the lift. So the acceleration of this block as seen by this person who is going to write the equation F is equal to ma, he sees that this block is going with 2 meters per second square upwards. So if acceleration is this way, it is actually this form, F is equal to ma. The direction of acceleration and the direction of net force, it has to be same. So when the acceleration is upward, I see acceleration is upward. It means the net force, resultant force has to be upwards. But onto this there are two forces, 10 Newton this way, F is this way. So eventually F should be greater than 10. Why? Because acceleration is upwards, so net force has to be upwards. So it is upward forces minus downward forces. So equation he is going to write is F minus 10. This stands for net force. I intend to apply F is equal to ma. So net force is F minus 10. What is the mass of this body? 1 into acceleration is 2. So F comes out to 12 Newton. So please do not jump to that is F is always equal to mg. the force which is applied on this may or may not be equal to mg depending upon case to case what is going to happen. Now the same thing I take it as, let's say this lift is going with 2 meter per second square downwards. Once again the force diagram remains same. But now equation is, because this is accelerating down, so it means the net force has to be downward direction, so that's why the net force is 10 minus F. That is the net force is equal to mass into acceleration, so F comes out to be 8 Newton. F comes out to be 8 Newton. So we see that the value has been changing. When it was not accelerating, it was 10 Newton, accelerating up 12 Newton, accelerating down with this 2 meter per second square, it is 8 Newton. Now, if I change the value, let's say I say that this is going up, suppose I say it is 3 meter per second. So now, what is the force that's going to apply onto the floor? Is it going to be more than 10 Newton or less than 10 Newton or so? Let's see that. So here, this is going up with 3 meter per second. Understand, this is velocity, 3 meter per second. Do not confuse with the acceleration. Constant velocity means acceleration is equal to 0. So equation is, suppose even it's going up and you intend to write equation F minus 10, net force, suppose, is equal to mass is 1, acceleration is 0. So F comes out to be 10 Newton. So if the block is, or the lift is going with a constant velocity, then the F is, in this case, is going to be 10 Newton itself. There's not going to be a change.